Hi, and welcome back to another episode of Mathematical Minutes with Mrs. Ross. This week we're going to be focusing on learning about 3D shapes. Let's start by figuring out what exactly a 3D shape is. Well, unlike a 2D shape, a 3D shape can be measured with length, width, and thickness or depth. There are things that seem to have a lot of different aspects to them, and we're really used to seeing these out in the real world. 3D shapes have things called faces. The faces are the shaped surfaces. Those surfaces meet at what we call edges. And the corners, just like we talked about last week, have a similar vocabulary word. We're still going to call those our vertices. So we're going to take a closer look at some of the 3D shapes that we are going to learn about this week. The first 3D shape that I want to talk with you about this week is a rectangular prism. And it sounds really fancy, but it actually is made with a lot of the same shapes that we talked about last week. Rectangular prisms are shapes that have 6 faces, so they have 6 surfaces. They have 12 edges, and they have 8 vertices. The rectangular prism is made up of flat 2D shapes like rectangles and squares. Let's take a look at some real life examples that I found around my house so that we can see exactly what those rectangular prisms look like. So as I was looking around my house, I found a lot of examples of rectangular prisms, and you'll probably find a lot of those around your house too, because they're pretty common. And I've picked 2 of them to help show those different characteristics that we talked about. Last week we talked about defining versus non-defining attributes. The defining attributes are those things that make the shape what it is. So if we think about the defining attributes of a rectangular prism, it needs to have the 6 faces. It has 12 edges and it has 8 vertices, and I have 2 examples here. Now, they're very different sizes, but they're still exactly the same 3D shape. We have the same number of faces, we have the same number of edges, and we have the same number of vertices. So the size does not make it a rectangular prism. Instead, those number of faces, vertices, and edges do. The next 3D shape that I want to talk to you about is the cube. This is one that you're also probably pretty familiar with. Like our rectangular prism, it has 6 faces, 12 edges, and 8 vertices. The difference though is that in order for a cube to be a cube, one of its defining attributes is that all of its sides must be perfect squares. So let's take a look at some of the cubes that I found when I was looking around my house. One is something you might be familiar with. It's a toy. This is a Rubik's Cube. It has the name cube in it. But you'll notice that with my cube, all of my faces are perfect squares. They're all the same size. They're all the same shape, making this a very good example of a cube. I also found a much smaller example of a cube. We know that the size of it is not a defining attribute. And we know that even though it's smaller, it still has all of those same defining characteristics. We still have our 6 faces. We have the same number of edges, and we have our vertices. So both of these, despite their difference in size, are examples of cubes. The next 3D shape that I want to talk to you about is the pyramid. Now, when you hear pyramid, you probably think about those things that are in the desert in Egypt, and that's true. Those are examples of pyramids. A pyramid is a little bit of a tricky 3D shape, though. We can't as easily define it as some of the other ones, like the rectangular prism or the cube, but there are some things that we can keep in mind with it. So a pyramid has faces or sides that look like triangles. The triangle is a really important shape when we're thinking about the 3D shape of a pyramid. But here's where things get a little bit tricky. The base or the bottom shape of a pyramid can be shaped like lots of different flat figures. It could be a triangle, it could be a square, it could be an octagon, it could be a pentagon. So for that reason, on this slide, you'll see that a pyramid has to have at least 4 faces, at least 6 edges, and at least 4 vertices. But those change depending on what the base shape is. And I'll show you what that looks like in just a moment when we take a look at some of the pyramids that I found around the house. Now, this one, as some of you, if you're a Star Wars fan, might recognize it as a holocron. This is an example of a pyramid. This is a triangular pyramid. You can see that all of the faces and the base, which is that bottom, are triangles. So this 3D shape, this particular type of pyramid, has at least 4 faces, at least 6 edges, and at least 4 vertices. But if you take a look, and the pyramid was kind of hard to find ones around my house, so what I did was I printed out something called a net off the internet, which you can fold into your own 3D shape, so that might be something kind of cool for you to explore. I printed out a square pyramid. So if you see between our 2 pyramids, this one, the base, has the triangle shape, and this one has a square on the bottom, which changes the number of faces, and it changes the number of edges and the number of vertices. But if you look, our sides are still shaped like triangles, making this also a type of pyramid. The fourth type of 3D shape that I want to talk to you about this week is a shape called the cylinder. And this is a shape that you probably have seen a lot before, like the cans in your cabinet. Trash cans are shaped like this sometimes. But the important thing for us to know about the cylinder is that the cylinder has 3 faces and it has 2 edges. On the cylinder, if we take a look at the two sides of it, we have circles. That circle shape is very important for making this into a cylinder. And then we see that one of the faces that it has is kind of a continuous curved face. So it doesn't have those straight edges like we're used to seeing in some of the other 3D shapes, but this shape is called a cylinder. So let's take a look at some of the examples I found around the house, and some of these might be pretty familiar to you right now. The first one, something you might be using a lot of lately, is this can of disinfectant wipes. This is a good example that I found of a pretty large cylinder. We can see that the ends, those faces, are circles, which we said was important to make it a cylinder. And then we have that continuous curved surface that goes around the middle. This is a good example of a cylinder, but I found a few other ones, and we know that they can come in different sizes. They can have different heights. So I found this was a little thing of lip balm. This is also an example of a cylinder. We have those circular faces, and then we have the curved face that goes around. Another type of cylinder that we have, still with the circles and that curved face. All 3 of these, despite being slightly different sizes, some of them are a little taller, some of them are a little shorter, they're still examples of the 3D shape called the cylinder. The next type of 3D shape that I want to talk with you about is called a cone. This is one that you're probably familiar with too. This one has some special features that I want to talk to you about. The cone has 2 faces. It has one flat face, that's a circle, and then it has a continuous curved face that ends at a point. Now, on a lot of the shapes that we have, we've been calling these vertices, where those edges meet. But on a cone, it has a special name. This is actually called the apex of the cone because it does a slightly different job. We don't have several faces meeting at one point. We just have that one continuous curved part that goes around and meets at the apex. So let's take a look at some of the examples that I found around the house. Now, finding examples of true cones was really difficult, so I had to get a little bit small with some of my finds. So I want to show you first, if we think about the top of this pencil, so the part that this is a mechanical pencil, but on your regular pencils, the part that you sharpen up here to this apex, this is a cone shape. And if we imagine if we could take this off of the pencil, we would have that circle at the base, we would have our curved surface, and then very top there at the top of the point of the lead would be our apex. I dug a little bit deeper and I found another example of a cone that's kind of an unusual one. This is a chopstick. And if we look at this chopstick, we have our rounded circular bottom. We have our curved surface that comes to a point here at the apex. You might be able to find some more examples of cones at your house, but I did not have very much luck here. So we're going to stick with those 2 examples and see if you can find some more as you're looking around. The final 3D shape that I want to talk to you about this week is the sphere. And I know that this is a shape that you are familiar with and that you're able to point out and identify, but I wanted to talk a little bit about the defining attributes of a sphere. Firstly, the sphere has no faces, really, no edges, and it definitely has no vertices. It's one continuous curved surface that really doesn't have a beginning or an end that we can see, but it's perfectly round. So let's take a look at some examples that I found around the house. So I found a couple examples of spheres around my house, and one of them is a ball, which is probably the thing that you thought of first when you thought of the shape called the sphere. We can see that it has a perfectly round shape. It has that continuously round surface. We don't have any vertices. We don't have any edges. And then I found a larger example too with my globe. And I know that that's a sphere that we've looked at in the classroom. So the globe that I have here, I'm not going to spin it around for you because it's honestly just a little bit too noisy, but we can see that this also shows that sphere shape. It has that continuously curved surface. It has no vertices and it has no faces. So both of these are very good examples of spheres, despite the fact that they are different sizes and different colors. Well, that's all for this week's episode of Mathematical Minutes with Mrs. Ross. Join us next week when we explore fractions. Say goodbye, Ella.